In this lesson, we're going to take a look at oxyion names. So we have looked at polyatomic ions already, which we have the list of in this data table with our periodic tables. And the ones that we are going to focus on today are the ones that have oxygens with them and that have an ending of 8. So the ion that is given to us and the charge from this polyatomic list. So we're going to use borate as our first example. So borate is BO3 and it has a charge of 3 minus. So if I use this for my example of borate, the ion that has 8 as its ending is the one that is given to us here in this list. And then the way this works is as we move up to the perborate or down to the borite or the hypoborite, the difference here is in a number of oxygens. So as we move from the borate up one, we are going to add an oxygen. As we move from borate to borite, we are going to subtract an oxygen, and then we're going to subtract another oxygen as we go from borite to hypoborite. So perborate then is the addition of an oxygen. So borate is BO3, so perborate is BO4. So it's one more oxygen. And the valence stays the exact same. So it is also 3 minus. And then as we move from borate to borite, here we have one less oxygen. So borate is BO3, one less oxygen is BO2. And once again, valence stays the exact same. Hypoborite, on the other hand, is one less oxygen than borite. So this one has 2 oxygens, so hypoborite is just going to have 1. And valence stays the same for all of these. So for all of the oxy ions that we have listed already in here, and we're given the 8 version, that will tell us the valence, and then the difference in number of oxygens will be based on here. So because you have this in your data table, you can actually pick an example and put those in there. And so you can highlight the bor part. Whoops, we don't want to get the 8. So that's part of the ending. So the bor part is the part that would get filled in over here for each of them. So let's just do one more example here together. So let's take a look at sulfate. So sulfate is going to be a common one. So I'm going to highlight the sulf part. And that is what we are going to fill in all of these. So sulfate is what is given to us in that polyatomic chart. Per sulfate is going to be 1 more oxygen. Sulfite is 1 less. And hyposulfite is 1 less than that. So you can write plus 1 oxygen, minus 1 oxygen, and then you can write minus 2 oxygens if you're talking about from the sulfate, or minus 1 from the sulfite. So you can decide what makes sense to you there. So this can be from here, it's minus 2. So that means per sulfate is 1 more oxygen than sulfate. So sulfate is SO4. So per sulfate is then SO5, and valence stays the same, 2 minus. Sulfate we're given, it's just SO4, 2 minus. Sulfite is 1 less oxygen than that, so it's SO3, and then still 2 minus. And then hyposulfite is 1 less oxygen that, or 2 less than sulfate. So it's going to be SO2, and then still 2 minus. So as we've been doing polyatomic compounds, if I have sodium, which is a 1 plus, paired with sulfate, which is a 2 minus, we can do our crisscross here. And so sodium sulfate is Na2SO4. SO4. So the 4 had a moment where I was thinking lowest terms, but the 4 is part of the SO4. So SO4 1, we have one of it, which means we don't have to write it and we don't need brackets around SO4. So if I had sodium hyposulfite, then what I would need to do is, as I come to here, I know that hyposulfite is 2 less oxygens than the sulfate that is given to me over here. So if I am asked for sodium hyposulfite, sodium is Na plus, hyposulfite, so sulfate is SO4, 2 minus, and then the hyposulfite is 2 less oxygens. So instead of 4 oxygens, 2 less than that, I'm going to have 2 oxygens. And so we have the same for the crisscross. Because the valence is the same for all 4 of these, the per, the ate, the ite, and the hypoite, the ratio with the same element, so in this case with sodium, the ratio is going to be the same. So this is also going to be Na2 and then SO2, because that's what hyposulfite is. So we need 1 unit of SO2. So that is how the per, ate, ite, and hypoite oxyions work.